This is the third part to the semi-log session videos. Part one, we looked at how do we read this gel, how do we look at this and analyze it to fill in our migration data. Part two, we learned how to set up semi-log graph, and this is part three. So we're going to graph a standard curve. So we're going to make a graph that looks like this, and then we'll use that graph to find out the DNA fragment sizes. So the first things first, we're just going to jump in. This is our marker here. So we're going to use the data because we have both our data. So this is our X data, the migration distance, and then this is our Y data, the base pair. So we're going to use this to make our standard curve. Our first pair is 1.1 centimeters and 54. Remember, the K means 1,000 base pairs. So 1.1 is here. So I like to just kind of take this ruler here and help keep my mind straight of which line I'm looking at. Set that up, and then I'm going to go up to 54,000. So I'll pull this down a little bit. So here's 50,000, and then this section here, there is 5 lines from 50 to 60, so we know each one is worth 2. So 54,000 will be 2 lines above that, so it's going to be right here. So I'm going to make my dot. So I did this one. Next one will be 2, 2, and 31. So I'm down here at the bottom. I'm going to go over to 2, 2, kind of straighten my line up, and that is going to be 31,000. It's just off that paper. So slide this down. So 30,000. Now this section we're in, there is 10 boxes between each number. So 31,000 is just going to be 1 box above. So we're going to go right here. We are going to go next to 3, 3, and 18. So I'm going to go down here to the bottom to 3 after the 3. 18,000 is going to be 2 under 20. So right here. So graph this one. Excuse me. 4, 3, and 96,000. So down at the bottom, I'm 4, 3 after 4. 9.6 thousand, right? So 9,600. So here's our 9,000. We're in the spot where there's 5 between. So we're going by 200. So 9,200 is 1 up. 400, 600 is 3 up. So we go there. 5, 5, and 5.6 thousand. So 1, 2, 3, 4, 5. So 5.6 thousand is 5,600. So again, we're in the spot where there's 5 between 5,000, 6,000. So each one's 200, 5,200, 400, 600. Right there. 6.5 and 3.2. So 3.2 is 3,200, which would be 2 up. Right there. So I've plotted all these points, X and Y coordinates based on my graph. Now I'm going to make my standard curve. Hopefully these lines line up. So they don't all line up perfect. So I'm just going to try to represent the line the best way possible, which is probably, that's pretty good. About like that. So I just kind of tried to split the points the best I could. So that line I feel like represents this data very well. If you're using a computer generated graph, or you could calculate the line of best fit to give you the exact line, but that's going to be good enough for our purposes. So now we can use this to find our data here. We're not going to do this whole table. I'm just going to give you 2 examples, get you an idea. So in this column here, in lane 2, from this data, lane 2, we found that the migration distance to the first band was 2.6 centimeters, and the migration distance to the second band Well, it's 4.9 centimeters. We have that in our table. So we can use this X data to find our Y data, which is the base pair size. To do this, we're going to go to our X number, 2.6 centimeters. So 1, 2, 3, 4, 5. So this is 2.6 centimeters right here. And we're going to go up until we hit the line. It hits the line right there. So now, where we find out where it hits our standard curve, we will go over from that point, and it is right there. So this is 20,000. Each line in this interval is 1,000. So 21,000, 22, 23, 24, 25,000. So that fragment is 25,000 base pairs in length, right? This fragment here is that size. This is way more accurate than trying to compare to our ladder. So then we'll do one more example. So this one is 4.9. So again, down here, I'll go to 4.9, which is right before the 5. And it's going to hit right here. I'll go over to the side from here. And it's going to be, it almost looks like it's between the 7,000 and the 7,200 mark, because each lineup is 200. So if I was between the 7,000 and the 7,200 mark, that would be 7,100. So that means that this fragment size here has 7,100 base pairs in length. All right, so that's it for the series. This was, remember, part 1 was, we need to look back. What are we looking at here? How do we measure this? How do we find out our migration distance? What do all these different things on the del mean? Part 2 was, how do I set this up? It's X and Y, and how do I read this? Part 3 was graphing and plotting the standard curve and using the standard curve to find our base pairs.